Welcome to the second Saturday layout tour of the 4th Division of the Pacific Northwest region of the National Model Railroad Association. Today we are going to have a presentation from Jerry Boudreaux of Oregon on his spectacular Santa Fe layout. Without further ado, I'm just going to turn it over to Jerry and we'll see his presentation.
Thank you very much. So Pasquinel Division is my rendition of the Santa Fe Railroad about 1967. I picked 1967 because that was a time that I remember in central Arizona, where I grew up in the ranch country. In fact, the Peavine division of the Santa Fe Railroad ran right through our ranch. And my first memories of railroads are my dad bouncing along the right of way in an old 47 GMC pickup truck and me hanging on for life so we could watch the engines. And I think the very first engines I probably remember were steam engines, because I remember a cacophony of sound, loud noises, big black stuff. And then I remember the blue and yellow diesels showing up, which were probably FTs and F3s. And from then on, it was all diesel stuff. So 1967 is kind of a magic number for me because I was pretty aware of the Santa Fe Railroad at that time. I had several goals in terms of dealing with this layout. The first one, of course, is just personal enjoyment. I just love doing this kind of stuff. Been doing it for quite a while. It's a demonstration layout. So people come over here and they say, hey, how do you frame one of these things? Well, I can take them right underneath and talk to them about it and show it to them. How do you wire one of these things? I can show them how I do it. How do you do that waterfall? Oh, well, it's pretty simple, just straightforward. So none of this stuff is rocket science. And then I can share the hobby through op sessions. So I used to have 2 op sessions per month. I cut that back to 1 op session per month. It's a crew of 14 to 15 people. And we start on Saturday morning and we run up until lunchtime or shortly thereafter. I make a few phone calls and we go have lunch, and then everybody goes home and takes their nap. That's our age group. The basics of the layout. So I drew a map here. Let's put us in geographical perspective. So here's the Colorado River. We have California to the left, Arizona to the right. We run across here. This is the Grand Canyon. And then we get up here into Utah, go over here to Four Corners, and then Arizona and New Mexico line comes down like this. The existing transcon for the Santa Fe runs basically parallel to old Highway 66 and the current Highway 40, Interstate 40, Seligman, Kingman, and so on and so forth. What I did is I have a freelance prototype. So I just kicked it about 40 miles south. So this dark line starting here at Eagle River and running over here and looping around through the mountains and coming back down again, and then coming over here to Pasquinel. That's an east-west line across northern Arizona. The place where I grew up is right here in the little town of Prescott, which is no longer a small town. One of the things we model here is what's called the Peavine. The Peavine used to come out of Ash Fork right up in here, and then it wandered down and wiggled around through Prescott, came out onto the valley floor, the Valley of the Sun, the desert, and then a straight shot down to Phoenix, which was right about here. That generated huge amounts of citrus and so on. So the layout statistics, at Central Arizona, 1967. It's in a 40 by 30 foot room, especially built for it. It's a linear design, so that means we walk along with our trains. The mainline length is 650 feet. The track I use is code 83, code 70, code 55, and believe it or not, code 40. That's mine rail. Those are in the mines, the little 18-inch gauge mine track. The switches are all Atlas number 6, 505 and 506s. Some of the switches on the main lines are number 8s, Shinohara. There are no switch machines on the layout. We set switches with our coupler pick, and we're able to get away with that now for about 15 years on these 2 layouts. Minimum radius is 36 inches, and that .040 represents the super elevation. 40,000 super elevation. People ask me, how did I arrive at 40,000 super elevation? And I say that that was carefully calculated due to the velocity of the train, the curvature of the radius of the curve, also the type of train that we were running. And the most important thing is that Home Depot was selling for sale signs made out of styrene that was 40 thousandths thick. So I cut strips out of the signs, and that was real cheap. It worked well. Our maximum grade is 1.7%. The train length, the design length, is 60 cars. So that is passing tracks, engine facilities, engine lash ups, etc. They're designed for 60 cars on a 1.7% grade. The control is NCE DCC. We have 15 boosters and about 50 power districts. The aisle minimum is 48 inches. That'll come up in terms of some of our pictures we're going to show. The height is 38 inches for the staging yard, 43 inches for the main level, the upper level. It's going to be up there pretty close to 6 feet in the air. This is an animation. This is very important. My train room is 40 by 30. My wife's barn I built for her is 48 by 60. Please note that's larger than the train room. The hay barn is 24 by 48, and the arena is 96 by 156. Those are all larger than the train room. Therefore, my negotiation for real estate is sort of taken care of. I made sure that her work stuff was bigger than my stuff. Here's a map of the layout, and we're going to refer back to this from time to time. So right here where this laser is, that's the east end and the west end of this layout, right in the middle of that big yard. Any trains that are running this direction are westbound. Trains that are running this direction are eastbound. So it's like looking at your old 8th grade map. You know, east is to the right and west is to the left. To follow this thing around, you take off. There's a long yard lead and a double track main. That's 3 tracks total. They come over here to wait. We have a bunch of crossovers and we get down to a double track main. Notice that this main line is behind the little town. So the guy switching in the town doesn't have to worry about getting his handcuff or his shirt cuffs drug off his arm by a passing freight. So this double track main comes out here, rounds the end of this peninsula through Apache Canyon, little town called Cottonwood, and then it goes zooming back here, makes the turn, comes down here through some whoops, and gets here to Willow Springs. Willow Springs is the end of the old main. We'll talk about that, and also the end of the double track. So at this point, the single track, it's still level, and you'll see this curve. This curve was laid off from the center point of this curve on the peninsula. So I laid off 36 inches, 38 and a quarter. I came out here about 44. And over here is 96-inch radius. And that 96-inch radius, super elevated at 40 thousandths, is almost 30 feet long. The trains look very prototypical going around that, and we're going to show some pictures on how that works. Once you make it around $1 million curve, then we start up this peninsula. Now, this peninsula violates the Lynn Westcott, Gordon, Odegaard rules. So that I'm in a passing track right here called Rufus. I come in here and do violation 1, where I penetrate the base of the peninsula. So all of a sudden, your train's on the other side of the peninsula. Exercise program is the operator is here. Train starts to disappear. He walks around over here and meets it. This is called Vulture Curve. This we'll see some pictures on that too. That's pretty neat. We call it Vulture Curve because in my little mind, the vultures are sailing off here thousands of feet in the air riding the thermals off this big cliff. We come up here, we penetrate the peninsula again, and we go around a place called Windy Point. We're up pretty high. We're up almost 6 feet in the air. We come across a couple of really nice trestles. Now we have to bleed this elevation off, so we helix down kind of a Tehachapi loop. We come down here, we go through Cibecue Canyon, and we come around the corner here, and this is where we jump over to the upper level. We cross over a bridge that just sets in. It's a 1x1 square tube aluminum. It sets right in place, makes its own contacts. That allows us to walk through. And we're into the town of Summit. We're still single track. We come to the end of Summit, single track over to East Granite Creek. East Granite Creek is a substantial town. It has a large refinery, a large cement operation. There's a question about Granite Creek right here, which is appears to be a great big long yard. And in fact, it is, because what I try to do is my towns have different personalities. So we're on the upper level here. And the idea is that switching the upper level, we don't want to do little onesie twosie car cuts. So what we do is we pull long cuts of cars, like 10, 15 cars off of each track from the refinery. We build a train of like 45 tank cars, and that leaves this town. Right over here is a cement plant. That's about 60 little short gray cement hoppers that come out of there. We pull them out 12 at a time. Over here is a long grain elevator, and there again, grain cars come out 60 cars at a time. So when we're up here in the nosebleed section, we don't want to be trying to set out 1 or 2 cars most of the time. We do cuts of cars. That way our switching is much less. This also is a four-track job going around here. So we have the main line, we have a passing track, and then we have 2 switch leads for the individual town itself. So we leave the town of West Granite. See, this is East Granite Creek here. We come into West Granite Creek there. At this point, we come around the corner. We do some country running along Bumblebee Creek, which zips back and forth. It's really kind of neat to watch a bunch of reefers snake around there. We come to the large town of Wickiup. There's 2 buildings in that town. And it just services a big mine up here called the Iron King Mine. Those of you who have been around Humboldt, Arizona, recognize that Iron King Mine was a great big thing. Right now, it's nothing but a massive headache for the EPA. Then we come around here through Twin Bridges. We're back onto double track right here at Alpine. It goes into a tunnel. We'll talk more about that tunnel. And we helix down, we bleed off all this elevation that we made up, and we come shooting out here at the bottom where it says B, and I'm going to come over here. Here's B. So now we are back at the base. We come through Eagle River, which is 4 double slip switches that creates quite an interlocking. And we have a choice of going into the yard or running the double track right through the yard. And sometimes if the yard guys are filled up and we don't want to hold up the whole main line, we just put another crew on the train and it goes around one more time. So that's kind of an overview, and we'll review back here to this layout map. So let's take a look at, we're going to stand in this aisleway right here. We're standing right about here. We'll see Yavapai, we'll see Ponderosa, and we'll see the upper level. So we'll go to that slide. Here's the town of Ponderosa. Here's the town of Eagle River. You can see that double track main in the background. So the trains can go whizzing through this town and they don't bother the guy switching here. Same over here at Yavapai. Here's the 4 tracks we talked about up in Granite Creek. Here's the big cement plant. Here's the grain elevator. And then this is the wiggly track going down along Bumblebee Creek. It's really neat to watch trains go down through there. We got a couple pictures of that. We move over to the next aisleway. So what we're going to do is we're going to stand right here and we'll see the mountain division to our right, and we'll see the town of Kaibab and so on to the left. So we go over to that slide. So here's the town of Kaibab. Some of the consistencies you'll see is the double track runs behind the town. This is what we'll call the old main coming around here. We can talk about that in a minute. Town of Kaibab. This is the lower level of Rufus Hill. It winds around and it ends up coming across these 2 big tall trestles, which they're really neat looking. I really fell in love with that after I built that. I thought that was pretty cool. Here's the upper level running along the backside and coming out here along the front. So this would be where the oil refinery is up at East Granite Creek. So let's move over one more aisle. I'm actually sitting right here, and the stuff that you see behind me is stuff that hooks up here and here. So I'm sitting right about here. Where that is on the map is right about here. So we're going to look over here. We're going to see the DSF, the diesel service facility, the main yard, and then Rufus Hill will be over here. So here's the diesel service facility. Now, mind you, the fact that the engine house has no windows, no roof, no interior detail doesn't stop us for a minute. We still have a great time. You can see that, there's probably 30 units in there, and those typically will be used during an op session. You'll see the main Pasquinel yard back here, and then Windy Point and several layers of mountain railroading right over there. And then this is the upper level with the town of Summit. Now, way back in here, you can't see it, but there's a almost like a Y track, and it penetrates this backdrop, and it comes popping out here at Red Rock, which is this town, and Camp Verde, which is this town. These are off. I didn't draw them on my layout map because, quite frankly, they didn't exist at that time. These were originally built in 0 and 30, all that Bachmann stuff, because I figured when I got really old, I'd be able to see the 0 and 30 stuff when I couldn't see the HO stuff. So then the guys were complaining. So we took out the 0 and 30 and we replaced it with HO. And so these are very complicated towns. We run a turn over there each op session, and the guys do a really good job there. So that's sort of an overview of the layout. How do we build this thing? You have to understand that this is not my first rodeo. I've done several layouts. I've developed the tooling and some expertise in terms of doing that, to the point where I've exported it to other individuals, and it seems to work pretty well. So what I'd like to do is talk to you a little bit about framing. And you can see an example of framing here. We're looking underneath that Rufus Hill. Almost all the pieces are made out of 3/4 cabinet grade plywood. That allows us to take a 4x8 sheet of plywood, put it on a unisaw, and rip out stringer stock, L-girder stock, roadbed stock, great big long 8-foot pieces of stuff, different widths. And all we have to do when we build the layout is we get a chop saw and we whack it to length and screw it together. So the L-girders, you can see one right here. Here's the top flange. This is the bottom flange. We cut these at 7/8. So the top flange is 1 7/8 wide with a saw curve that gives you 2 inches, evenly divisible into 48 inches, no waste. The web is 3 7/8 inches tall. Again, it turns out to be 4 inches with the saw curve, 4 inches evenly that goes into 48. Again, no waste. The stringers are 2 7/8. Here's a good example of a stringer right here. And the sheathing, which is going to hold up this cork and this yard, that's just 3/4 plywood with a 1/4-inch cork on top of it. Pre-cuts. So when building a layout of this size, the club layout did this. I've done it for other people. They come over with a pretty specific framing plan, and then we can pre-cut out of plywood their L-girder stock, their stringer stock, their riser stock. We can make a fairly close calculation of what they're going to need. So they don't have to make these big long rips. All they do is cut them to length and put them together. That seems to work pretty well. I've done it for a number of people. One of the better known folks was the Ashland, Oregon layout of Tom Dill. Some of you might be familiar with his books. We put together a pre-cut package for him, and he went home and just basically had a kit, and it worked out real well for him. The legs, we make them out of 2x6s. They are ripped in half, and then the diagonal braces for the legs are 1/2-inch EMT, which is like a thin wall conduit that we can screw together. Sub-road bed and road bed. So we use a 3/4-inch cabinet grade plywood for sub-road bed, and we connect it with pocket screws using a Craig's jig. It's a really nice way of putting together cabinet work. I can go into greater detail that at some other time if anybody wants info about that. I use Midwest cork for the main lines, sheet cork and 3/4 ply for the yards. Here, this is 3/4 plywood. Here's a 3/4 plywood stringer. You can see how we drill holes for the wiring. And then the Midwest cork is glued with acrylic caulk to the plywood. And then the track, and you can see how this is super elevated. There's a piece of the for sale sign from Home Depot, that white and red stuff, glued down with poly seam seal acrylic caulking. You'll recognize these buildings here. They're Glacier Gravel and New River Mining, just kind of spray painted gray and stuck there as a placeholder for a little while. That's the Iron King mine. I want to talk a little bit about variable risers. This is a thing that you don't see very often talked about. So if you look at the bridge pier right here and consider that the base is down here, the bridge is up like this. And this is a finite measurement from down here to the plate. And then I poured these homemade footings. And so from here down to the plywood has to be pretty exact. So what I do is I put a 10-degree cut on whatever piece of wood I'm going to use there. And then if I slide this underneath there, you'll see how it ramps it up very accurately. And I don't have to measure and cut super accurately. I do that with for bridge piers. I also do it for risers because I set my grades mathematically. And then the variable riser once in a while is real helpful to get that exact dimension. I put glue in the joint after I figure out where it's going to be. I slide the pieces to the accurate height, and then I use a pin nail. The pin nail drives diagonally right down here, and that holds it together. And that gives us really nice support, and it's very accurate, and we don't have to try to use our saw to get right down to a 32nd of an inch. The track itself, we use several codes of microengineering and Atlas 83 and microengineering 70, 55, and 40. The flex track is glued down with poly seam seal clear caulk. The switches are nailed. That way, if we have to replace the switch, we just pull the nails, sweat off the rail joiners, pop the switch out. Mainline crossovers are number 8. Everything else is a number 6s. The curves are super elevated 40 thousandths, like we said. And about every 8 feet, I put a rail joiner in with no solder because that's an expansion joint. However, there is a hard soldered lead to that 8-foot section of track rail so that I don't get any loss in my DCC signal. Weathering flex track. Some people use flex track and then they don't quite know how to weather it. If you lay the track down using the aforementioned process, and I just spray it with a camouflage brown. It's a fairly typical True Value hardware paint color. And then I use a light brown wash on the ties, a very dilute acrylic paint. I use craft paints, the cheap ones. And then I add a gray wash to a few of the ties. And then I kind of blot them down. I add dirt, spread that around. I add the weeds. And then I add brake bushes if required. And so you can see that over here where the rails and the ties all kind of blend in together. Once in a while, we have a spur like this coal spur that comes up here. And the cars like to roll off. Well, right about here is something that looks like this. We call these brake bushes. So you can shove a car through the brake bushes. When you uncouple, if the car wants to roll, these little Woodland Scenics or Scenic Express clumps will capture the axle and won't let it roll off the hill. When I scenic the yards, I put down a real fine material in between the tracks, and then a little rougher material goes in there for what used to be ballast years and years ago, and a little bit of green foam and little clumpy stuff, and kind of make it look like there's water standing there and there's been bushes growing in the yard. The wiring, more specifics on the wiring. We have wire runs are 12 gauge stranded twisted pairs. That is, from the PSX circuit breaker out to the track, we run 12 gauge stranded, and I run them in pairs. The drops, that is the wire that goes up to where the track is 14 gauge stranded. And then the last 2 inches of that drop is a 24 solid copper. And that's what actually solders to the rail, penetrates the roadbed and solders to the rail. So the question is, the drops are attached with these 3M suitcase connectors. The maximum length of each run is 65 feet with a PSX in the middle. So that means I'm not pushing more than 32 feet out from each booster. And that keeps my signal strong. And the reason I do that is because I'm not a DCC understanding person. All I know is that Seth Newman told me if I did that, it would work. And it does. So let's take a look at this. Here's our number 12 twisted pairs. You see it's a black, yellow, a black, red, black, blue. They come up and they go through here like this. Then we have the suitcase connectors. You'll see a white wire coming out of here. That's a number 14. They come up here. Here's that number 24 copper that penetrates the plywood and goes up to the track. And so our wiring is pretty much color coded and we can track it. So here's one of my panels. I hung it from the L-girder so I can roll up to them in a chair and work on them. I don't have to lay on my back and underneath the layout and so on and so forth. I use the NCE 5 amp boosters. I use PSX circuit breakers. That's the green boards in the back. Power districts are wired in pairs and they're color coded. Here's the color coded wires coming down here into the terminal strips. These black and white wires, they simply come off the booster up here on top. You can see it better here. So this is PSX number 2. It comes down, winds around, and feeds in there. Number 3 does the same thing, number 4, and so on. So this 5 amp booster feeds into the bottom of these PSXs. This feeds out the top to the terminal strip, and from here it runs out to the layout. This little guy here is an automatic reverser unit on one of the sections, and these are the power supplies for the boosters. If you look close, you'll see this is booster 9 and 10, 11 and 12. We use a lot of boosters on here because we run pretty big consist of locomotives. So the scenery shell, we're getting to the end of this part of it, guys. The scenery shell, we kind of want to talk about. The sub-road bed is in place. The scenery defines the bridge, and we paint the plywood black, and we add a bridge girder later. So what we're talking about here is that if you're putting in the scenery and you come to a place where you need a bridge, and that's pretty obvious right here, what I do is I run the plywood right straight across there. I don't put a gap here or a gap here. I run the sub-road bed and the fork and the rail. So I don't get these dips and bumps right next to the track whenever I can do this. And then at this point, I've got the scenery in, the MDF abutments and bridge retaining walls and so on. Then I just come in later on and right to this surface, I glue a microengineering or an Atlas bridge girder. And that works out pretty well. So here's the temporary bridge, the plywood that you can just barely see here. That's still in place. All I did was just glue up this girder to the edge of the plywood, and it looks credible. There's no vertical joints or bumps, and I use microengineering, Atlas, Central Valley, those kinds of products there. The abutments are made from 1/4 inch MDF. I drag it across 80 grit or 40 grit sandpaper, which makes these forming lines. Right here, the form lines there and there. So let's take scenery 1, 2, 3, 4, 5, or A, B, C, D. So here's what scenery kind of looks like when it first starts. There's cardboard that's welded together with hot glue. You can see a hot glue joint here. You can see hot glue along the bottom there. And then I use foam to create some more forms. And then I use plaster cloth to fill the joints. You can see where I pretty much know what the scenery forms are right here. And look at here, we've got abutments that are already glued down, and we bring the scenery up to them. So that makes them match quite nicely. So here's another, the rock castings have been applied. So rock castings are right over here to the right. Some rocks are carved out of a plaster mix that I use. So these are carved rocks here and here. Sculpt-A-Mold smooths out the contours, and that's all Larry Volt's fault. I didn't used to use Sculpt-A-Mold, but he told me I should, and I'm addicted to it. So then the MDF, the river right down here is just flat MDF, and we'll talk about how we put the water in there in a minute. So we add a little bit of color, brown wash and black wash. Temporary bridge is not even in place yet, and that's good enough for operation. We operated on my railroad, and it looked like this for a really long time. I'm talking, 3, 4, 5 years, which allowed me to come back at my leisure and do small places, super detailed. So here's the river water is painted in, and we'll talk a little bit more about that. The bridge is in place. So this is a scenery shell. This is just painted water. It's not poured, and it's tumbling over these rocks right here. The white water is kind of stippled in there and so on. In the back, let's talk for a minute about Alpine. Alpine is a place on this layout where 5 tracks crossed underneath each other. So I have a helix in here. I've got these 2 tracks and another one down below. And I had to maintain that clearance. That meant that I had to calculate the grade back about 200 feet to figure out where it started for all 5 of those things. Now, this in turn created a complex scenery situation where I had these tunnel portals next to each other. How do you hide that? And it occurred to me, if this was the original line and then maybe they put a new tunnel out here. So I thought I'd try that. So I mocked up some foam real quick, stuck it around there, put in a couple tunnel portals. I laid down some saran wrap here so that whenever I poured the rocks, I could have a real close joint. And this kind of looked okay to me. Thought I might be able to work with it. So now I applied the Sculpt-A-Mold, put a little bit of wash on it, and live with it for a little while, see how it works. Had a couple op sessions, listened to what the guys said, and it was pretty good statements about this. So then the trick is, how do you take this thing and blend it in? Because we've got this joint along here. Well, you use some rocks and some clump foliage, and you can kind of blend it in, and there it is in place. You can see how the rocks and bushes conceal the gap. So here's Alpine. This is Alpine at work from the aisleway, from where you see it. And then if you zoom in a little closer, this is a kind of a picture that would be passable in terms of if I learned how to use Helicon focus stuff, probably make a pretty good picture. Right now, that's what we see. Our 251 East grinds uphill through the 51 tunnel as 47 slips out of Alpine and into the old tunnel. So let's talk ground cover a little bit. Starting from the left, we have rock castings, and we have we color them with spray, acrylic sprays from water bottles, and then the talus is homemade. So let's take a look and see what that stuff is. So here's rock castings. These happen to be from Bragdon, Joel Bragdon. We color them with spray bottles, so we don't have specific colors. They just kind of bleed together. And then these are the rocks that fell off the cliff, called talus. And then we put some brush around them. The dirt is homemade. I sifted out myself. Woodland Scenics foam, Scenic Express weed clumps. And oftentimes, this is about as far as my scenery goes. I haven't gotten to the point where trees are growing yet. You'll see a lot of pink foam on my layout. And what I really like doing is being able to take a little 2 or 3 square foot piece like this and kind of focus in on it and bring it up to spec and then move on. So here's our painted water. So I use flow ease with acrylic paints. That means they last longer. They stay wet longer. They're easier to blend. I use blending brushes. Blending brushes are rounded on the edges so that they can blend the paint together. This is just a flat piece of plywood right across here. And I paint the plywood is all painted brown. The brown becomes part of the mud along the creek. Also, like right here where my ground cover isn't complete, it shows through as kind of like a little mud hole or something. So I dump a little bit of sand, a little bit of green, some bushes and so on along here and define the creek. Then I take my evergreen paint, and I'll show you what that is. I paint it down the middle. It's wet, so I can blend in a little dark black in order to make it deeper. And then I blend in along these edges here to make it look like the water's kind of sneaking up on the dirt. And then I let it dry. Then I come back a little later and I rip a piece of paper out to create this joint right here, a rough piece of paper. And I stipple downward, dry brush, a little bit of foam. So it looks like it's hitting some sort of thing in the water and rippling and foaming after that. And then I put a seal on the top of it with a material called glossy Mod Podge. And so the water is about a 32nd of an inch deep. I'm thinking about this glossy Mod Podge does not dry hard. My idea is to put some future floor wax on top of that and see if that'll actually work. So here's an example of painted water. Here's a waterfall. I'll show you how we do those. Here's Apache Canyon. This is a deep canyon, rushing water. Not all the way finished yet, but it's close. Here's the colors that I use. So this is all cheap, $1.50 per bottle. And I use black and white and gray. And then I use green, evergreen, and raw sienna as the color for the water. Waterfalls. Here's a good example of how I do waterfalls. So I spread out this clear caulk on a piece of glass. I furrow it with a toothpick and I let it dry. And then I cut it to size and peel it off the glass. And I use the clear caulk as a glue. And I stick it where I need the waterfall. And then once it's in place, I dry brush it with white. And that creates a waterfall. And they're kind of portable. I can put them where I want them. There's an example of one of these kinds of waterfalls. So the glue would be at the top right here, and then more glue at the bottom, and then dry brush white right down there, and then stipple some white in here, and smear that super gloss Mod Podge on top of the whole thing. Foam core structures, these are temporary structures. Some of them go back 20 years. They're just printed paper that I glue to foam core with rubber cement. And I use 60,000 styrene for the roofs. Right along here, this is a little B&B camp. These little buildings have lived on many layouts in many places. And they're real quick and dirty. And I'm having the Railroad Club is starting to build those. they're making bunches of them. They don't cost much, like 25 cents a piece, and I like them. So this is where we take our break.
So let's do some Q&A now. I know I have two questions. How did you make the gap from 14 gauge to 24 gauge? Did you do that with soldering?
Yes, 22 gauge solid copper, like here. And then I strip back, I hold them in parallel with little alligator clips. I use paste flux
Yeah.
and then wet solder them together. And then I put shrink wrap over the top.
The second question I have is, you mentioned you're only flipping your turnout points with picks. How do you get the turnout points to stay in position if the commercial turnout doesn't already have springs in it?
That's a great question. And it's one that I get a lot when people come down here to operate. They go, wow, wait a minute. How's the switch going to stay put? So I want to show you one of the little picks that we use. This is a skewer. And then I put a yellow molly on the end of them to indicate that it's mine. Now I give a speech about these skewers because this is what we throw the switches with. So with a pick, we flick the points on an Atlas 505 or 506 switch. That keeps us from getting finger oil on the track. And we also use these to reach in between cars, pull the little air hose glad hand out, and if they're slack in the KD couplers, it'll uncouple. Now, the idea behind the switches being thrown without a switch machine, the secret there is that if you inspect the points on an Atlas 505 or 506, you will see that not only it's sharp, but it also has a vertical gathering angle on it of about 15 degrees. The point itself, like this is the rail that goes back and forth. And what they do is they've taken a piece off of that rail like this. So when the flange of the wheel comes across there, that flange comes down on that gathering angle and forces that point up against the stock rail. That's the only thing I can figure out. Now, we run 50, 60 car trains on this layout, and we very seldom have derailments due to points flopping around. Out of 5% of our switches, we put Caboose Industries ground throws on them because, in fact, they do flop around. One of the conditions is if you're coming into that switch from a curve and you have an inordinate amount of side thrust on the wheel, then sometimes you have to use those ground throws. But for the most part, the guys really like the picks because it's direct action. And the layout owner really likes the idea that at 80 years old, he doesn't have to climb down under the layout and install toward a switch.
You calculate your grades mathematically. I don't know if you have any further comments on the engineering that you've done behind the scenes to improve operation.
So basically, a 1% grade, roughly in HO, is 1/8 of an inch per foot. So that's 0.125 rise for every 12 inches forward. There's a couple ways you can do that. You can mathematically calculate how many feet you have and how far up you want to go. And if you come out with something that's 0.125 per foot, that's a 1%. If you calculate it and you come up with something that's 0.250, now you're talking 2%. You can also cut a piece of wood and mathematically derive how wide, how thick the wood is, put it on the end of a level on one end. So you have a level and you have a block of wood here and you put it on the sub road bed. And if the level is level, then you have that much rise and that much run.
How long have you been working on this layout, you and your crew?
This layout started in 2014. It's not a crew, it's Jerry. And people ask me, well, why is that? How come you don't have others help you? It has to do with quality control. Other people come in and they want to help and they bust their butt to do the best job they possibly can. And then I have to go fix it, or it's better than my work and it makes my work look terrible. So I just do the work myself. So I don't use any extra help on layout other than, well, I got a couple guys over here running trains right now, and I mean, Larry Vote's sitting here making sure I don't fall out of my chair, and Doug's having a good time running trains around. I told him to mute all of them so that I can hear if something hits the ground.
The most dreaded sound you can have in a model railroad.
Yes, we experienced that at the last op session. We had a passenger train stopped on the main. We had 6 SD 45s coming down the hill with 60 cars, and the engineer was running his mouth on the other side of the peninsula. And then we heard the dreaded sound with those $100 Walthers passenger cars somersaulting to the floor. The carpet saved us, but he had to buy me lunch.
Switch machine controls, was that all done manually?
Yes, John, we don't use switch machines, so we manually move our points.
Even the double slips?
The double slips have Caboose Industries ground throws on them. There's 4 of them in the interlocking. So it's like a double crossover times 20. The regular runners down here kind of know how to set up those switches, but the new guys, on the SP, I worked for the SP for a while, and they call them puzzle switches. So I have Lonnie, he's the tower operator, but we also have a set of trucks, just loose trucks, sitting right there so the guys can try it out. They set up their line and they run the truck through there very nicely. And if it works, it works. If they don't, try it again. I did have one person come up to me holding the trucks in his hand, not knowing that they were the trial trucks for the interlocking. And he said, Jerry, somebody's got a train in real trouble on the layout. He thought those trucks belonged to some train running around on the layout. But we just keep them there and they try it out.
I was reluctant to try any double slip switches in my staging yard until I visited your layout and I saw someone back a long freight full speed through all your double slips with no problem. So I thought, wow, I can do this too.
That's a great testimony. I appreciate that. Thank you. Who was the clown back on the train through all the double slips? They run pretty nicely. And man, they save a lot of space, but they have their place. You don't want to scatter them all over. Randy Stockberger actually created a software for me that I can install, put in the switch machines, and it's a 2-button thing. The entry point and the desired exit point. You push the 2 buttons and they all line up. I haven't done that yet.
Well, I think at this point, if there are no more questions, we can end the meeting. I want to assure you that the second section of this presentation is going to be equally fascinating because Jerry has an extremely well-designed operating scheme with a lot of really useful paperwork that I'm planning to copy myself. So I encourage you to join us the next time that we have Jerry scheduled. And thanks for a great presentation, Jerry. We'll look forward to the next one.
It was my pleasure. I really appreciate the rapt attention, and yeah, please come back because we got some other stuff and got some pretty nice pictures and stuff to show you.
All right. Well, see you all somewhere near here having to do with trains.
See you later.
Bye-bye.
Take care.
Bye-bye.